And I'm doing my presentation for assessment 4.2, and I chose the client server systems and web-based database questions. That's where I've worked for almost 2 decades now. Um, Web-based programming is what I do for a living. So TechSmith wasn't working, so I had to download and learn how to use some screencast software to do this. But I think this is working, so I'm going to proceed with the presentation. First question is the advantage of client-server systems is improved security. Could it also be a disadvantage? Why or why not? Um, it can be a disadvantage depending on the software that you're deploying, distributing, and what the client operating system is. If you've got a big variance, they're patching middleware, getting bug fixes pushed out, you have to deal with the security on the client machines. So especially if you're in a wide area network or in multiple locations, getting software distributed used to be a big problem. There's a lot of ways to automate that now and do that type of thing. Still involves a lot of security to allow access to distribute software. You need access to the machine to distribute it or do upgrades. Um, from the web-based perspective, the lack of the ability to do uh, use storage on the client, you can't access like the C drive of a client directly anyway, and you can print through a browser, but for web-based applications, you almost need a completely different CSS and uh, layout for printing because web pages aren't necessarily designed for printing. But um, there's ways around all that, but it does mean that you have to consider some of the security implications of the client machine and even what browser they're using. So, next question: disadvantage of client-server systems is a single point of failure. And what does this mean? The best way to explain this is the metaphor of the weakest link in the chain. If you consider a system of client-server applications where you have your application server, your database server, then you have the individual workstations or whatever the input method is for the application. If you're talking about a server going down, or whether it's a database server or a web server or uh, an application middleware server, if it goes down, having the other servers really doesn't make a difference because all of the servers are needed to complete the application's transaction cycle or whatever, if it's a request response, whatever it happens to be. So in a lot of cases, it means if one component fails, the entire system fails. With a lot of the way end-tier applications are working now, though, you could actually have only degraded performance and some self-healing stuff that goes on. But whenever you have one component of a system go down, it's going to at least degrade um, the performance of the overall system. You might not be able to do all of the functions that the application would normally provide. You can only do some of them. A good example of this that happened recently in my work was a database that controls login stuff for multiple applications. That particular database went down, so not the database server, but just that database had problems. And instead of only impacting one application, it impacted multiple applications. So that login database that was having trouble was the single point of failure in that particular system, and in fact multiple systems, because it affected multiple applications. The next question: which situations would you want to ensure that some type of backup system is in place? From my experience, all situations. There's another question coming up that references the Google applications or the online type things like Google and Dropbox. And in fact, I love Google because it saves almost after every keystroke. So it's got a backup and it keeps versions. So you can actually go back and see what a document looked like 2 times ago when you edited it if you want. And that's like a built-in backup. But whenever you're talking about a business, institutional banking that I'm in, everything on our databases is mission critical and subject to FDIC regulations, and about 20 other federal agencies can come and look at it whenever they want. And we have personally identifiable information in our systems that needs a lot more security, and keeping that stuff hidden from people who would use it for bad. Those types of things, we have multiple layers of backup where we actually have a data warehouse that is a near real-time backup, and then an actual system that moves our data from a SQL database to a data warehouse on an Oracle database, and that doesn't even include the nightly, weekly, and monthly backups where they're doing, backing up the logs, backing up everything about our system, and because there'll come a point when something will fail and you'll need to restore a backup, or you need to get back to where you were, and whether that's a system glitch or a man-made disaster, natural disaster, whatever. One of the things that we do at my company is business continuity planning, where we practice, something bad happening in one of our data centers going down and having to reroute all the traffic and bring up systems in other data centers, so that the business can continue. And when you're talking about wholesale banking, the stuff that I'm doing, millions of dollars moves through our systems every hour, and when people don't get their money, especially large, federal agencies and entire school districts, things like that, when they can't get their money, they start to complain rather quickly. So being able to not only have the backup, but being able to use it is also very important. So everything from the smallest thing of just keeping a copy of your important documents on your own computer. I happen to use Time Machine on my Mac, and it saved me a couple times with stuff that I thought I had put somewhere where I could get it and I couldn't, and I had to go back and find it. But all the way up to backing up entire millions of rows databases, being able to bring that back up in another data center, for example, or on another database server, should it be a server problem. That's always been super important and a big part of what I do every day. What is scalability? Scalability is basically the ability to expand and to accommodate. And the scalability, when you're talking about client-server applications or databases, it means that as the need gets bigger, so can the ability to handle that need. And it also means as the needs change, the ease with which the application and the entire system can be enhanced, upgraded, functionality added to meet the growing consumer need. And I do also want to say it means using the appropriate amount of stuff. So if you did have a big need and that suddenly dropped off, and you had expanded your system to handle millions of transactions an hour, and you're down to hundreds of thousands, then you don't need all that computing power anymore. So scalability can go up and down. Parts of scalability in software development, software design, and database design is that anticipation when you're designing something, knowing kind of ahead of time that this is a place where if we need to do another function, here's a good place where that could go. And you're kind of thinking ahead when you're doing the design and not setting yourself up for more work. And basically that's the key to anything being scalable, that if it was set up to be easy, then it's scalable. If it's difficult, if you go from $500 a day on an online store to $500,000 a day, and you don't have the server capability to handle these additional customers, and you don't have the software to handle all of these additional orders, that is an example of something that's not scalable, that an increase in traffic or an increase in customers, which are good things, actually crash a system, can't handle it because it wasn't scaled up to handle the additional load. The next question, what is backend processing? The backend, or back office, sometimes you hear it called in the bank anyway, it's the part of the application that the user doesn't see. It's the response to what they're inputting. So if they're inputting a form and they hit send, they hit enter, what happens that they don't see on their screen is the back-end processing of an application. So it's inserting database rows, or it's doing calculations and providing output that they will eventually see, but the processing that creates the output, that's what back-end processing is, and it's also referred to as the heavy lifting. And I don't know if that's because back-end programmers and design guys kind of clash once in a while, or it's the harder stuff. It's getting into databases and doing complicated SQL or complicated algorithms or a lot of functions that happen so fast that the user doesn't know they're happening, but it's the stuff that doesn't appear on the user interface, basically, is what the back-end processing is. And it's either something that's scheduled and run on a schedule. An example of that is monthly invoices get sent out, and that can be triggered by a schedule, or a user can actually hit a button. But the back end is the response to the input, and it's the purpose of the application. It's your business logic, and it's your non-display oriented aspects. So of course the next question is, what is front-end processing? That is the processing that happens on the client or in the web browser that handles the input, displays the output that the backend sends it. On very simple programs, it could be command line. So when the user enters a command, backend processing happens and it sends a response back to the command line, whatever the result was. Web-based applications, the same type of thing, is that a web-based application still is ultimately a web page when it reaches the user. So all the back-end processing happens when a user inputs form data, or a user makes a selection to change something. That input then is processed on the back end and creates the HTML that is ultimately displayed at the end of that request. That's a real oversimplification of web applications these days, especially with Ajax and some things that will come up in later questions. But front end is what the user sees on their screen. It's their visual feedback, or their what they read on the screen as a result of some input that they've given to the program. I like this question a lot, and in fact, I put it out in my paper that this whole paper, the text and the slides and everything are Google Docs. I've used it in a lot of cases, sharing documents with sports teams. You know, you share your rosters, and the moms do snack days and things like that with all the teams that I coached. One of the things that I learned, and I actually got an opportunity to teach a 2-day community ed course on all of the Google applications, and as I was learning the ones that I don't use frequently and stuff, I realized that they go together very well. It's super easy to combine things from each of the applications, and they're linked really well. I mentioned in my paper that you can get to your task lists from anything, Google Slides, Google Sheets, wherever you are. If you think of something, your task list is right there, you know, and then you can add a task, and later on when you're off your computer, you can see it on your phone. You know, you can set reminders and things like that, and it's a lot like Microsoft's Office suite, except you don't need to start off with a dummies book and then go to classes to learn how to use all of the functionality of it. I noticed that things that take some effort and quite a bit of time in Microsoft Office, you can do with a lot fewer clicks on Google Docs and get the same result. And in fact, you know, download the Google Doc as a Word document, send it to somebody who has Microsoft Office. So that's my experience with it is I taught 25 people how to use almost everything that Google provides in 4 hours, and it, it it's anybody can use it. It's free, you know. Um, and you hear the complaint, oh, I don't have a Google account. You don't need a Google account. You can use whatever email address you have. Um, so the examples of me using it are endless. So I'm not going to spend any more time on it. Just that I'm very familiar with it, and I've used it. I use it whenever I can, rather than using Microsoft Office. Research client-side scripting languages, JavaScript, jQuery. Um, I've actually used a lot of jQuery, and I used to write a lot of JavaScript. I had to stop that because nobody likes to write a lot of JavaScript. Um, but the JavaScript libraries that are coming out, there's a lot of them. jQuery is obviously the most popular because that's the one that comes to mind when people mention this. But what they're doing is moving some of the processing from the server back out to the client because JavaScript it's not Java, so it's not an object-oriented language. It's strictly scripting, but the things that it can do as far as depending on which library you use, you can create single-page web applications that are responsive. They work on PCs and mobile and tablets, um, and they use processing power, and they use the browser's interpretation of HTML and JavaScript to do a lot of really cool things that you used to have to do server side that generated HTML and then presented it to the web browser. This way, using JavaScript, the web browser is actually doing the work, and it's actually using the processing power of whatever device it happens to be on to do that work. So some things that these libraries are really good at, manipulating the document object model. Um, browsers sometimes handle the same code differently if they're a different browser. And one of the great things about jQuery is that it keeps track of the browser for you, and it will display properly based on the browser that's executing it. So it's taking away some of the things that you would normally have to code yourself, and just automatically doing them for you. Um, it really helped me learn how to do AJAX calls and deal with the responses because it simplifies it a lot. From um, writing an AJAX call in straight JavaScript is painful because you have to remember a lot of things. And my example was like error handling. Every time you do anything in an AJAX call, you have to handle the good and the bad. And if you forget one of those, nothing works because it's JavaScript. Um, but the simplification that jQuery provided, it took care of the error handling for you. You provided what you wanted to send to the server and what you wanted back, and all of the minutia and all of the actual JavaScripty stuff is done for you by the language, by the jQuery components that you use. There's tons of plugins for jQuery, so somebody will come up with something that they want to do that they think other people are going to want to do, and when they write the JavaScript for that and put it into jQuery, because it's open source, so people can contribute additional plugins and things. The big summary of it and what you can do with it is you don't really have to ever code anything from scratch anymore, especially using JavaScript or some scripting language, because somebody's already done it and you just need to find it. And 9 times out of 10, you can find a jQuery plugin that does what you want to do, because as original as we think we are not the first person to think of something. It's been done before. And then lastly, the last point on there that I didn't mention is that not only Ajax and manipulating DOM, you could actually do some animation and some Java swing type things with jQuery. Other languages, other libraries also have really intricate user interface design stuff and graphics. That is great, but HTML5 is making a lot of that even easier. HTML5 is really a move towards mobile devices, and being able to interface with speakers and sounds and all of the different hardware things, um, and it simplifies it to the point where you don't really even have to know what the device is, and your tag in HTML5 is literally video, and you provide the file name, and the browser takes care of the rest. So that's pretty exciting stuff there. Next question. .NET, Ruby on Rails, Python, developing frameworks, and then PHP is a scripting language. Instead of doing a ton of research on this, I know I've used all of those at some point in my career. But the main thing I've done my whole career in IT anyway is Cold Fusion, product developed way back in like 95, 94 by two brothers that went to McAllister College here in Minneapolis. Then it was eventually sold to Macromedia was the next company, and then Adobe bought it from them, I believe. So it's Adobe Cold Fusion, and it's on version 16. I've been on it since version 1 when it first came out. Real similar to PHP in what it does and in the way it works. I'm using PHP for the classes that I'm doing here that involve web development, and so PHP is probably my second web scripting language, and then Cold Fusion is obviously my primary. I've got some opportunities to teach some courses on that language as well. But to summarize the points, .NET is like the 150th version of ASP, Active Server pages from Microsoft. It's been around forever. I reference in my paper a little bit about how extremely old I am, especially for this business, and what I did with ASP before .NET was even a thing. It hadn't been invented yet. .NET MVC is an actual programming framework, an application framework that uses model view controller. I use a lot of model view controller frameworks in Cold Fusion, and so that development pattern is similar across the languages. Ruby on Rails, I haven't done a ton of that. Ruby's a pretty simple programming language, and then Rails is technically the framework that it goes on, and it's a lot like a lot of development frameworks that you develop each component one at a time. So you do your security component, and then you do your kind of content manager, what's going to display on the main page, and then you can do things with database processing. You can hit databases and get data and do inserts, updates, deletes, and things like that through their framework. And the only thing is that Ruby as a language never really took off. So I don't know, I haven't heard of a Ruby on Rails job being advertised in quite a while. But and then from what I know of Python, I've used Python a couple times on the mainframe, and a few times there was some processing that there was a Python process that ran in a web application, and I don't exactly remember the interface, but I remember having to write some of the Python code to improve the process and handle some additional cases and things like that. And from what I know of it, it's pretty standard language that you can use for multiple purposes, not just web development or client-server development. So not necessarily a framework that goes with that one, but basically for web applications especially, which is what .NET is generally used for, and Ruby on Rails is primarily used for that. PHP and Cold Fusion are really similar. They're both tag-based. They're both, and by tag I mean they're embedded in the HTML. So when you write a web application, you're writing HTML and putting the Cold Fusion or PHP code within that document in the right places to do what it's supposed to do. And if you're using a framework, then of course you put the Cold Fusion stuff where the framework tells you to, and then it sets up your outputs and your queues and all of your buffers that it does processing into before it assembles the final page that's sent to the browser. The way that the Cold Fusion PHP works basically is an application server is sitting on top of the web server. So when a request comes in from a client, the web server can tell whether it's a Cold Fusion request or a PHP request. And so before it does its job at all, before IIS does anything, or Apache or web server it is, it sends that request up to the application server where the code is actually parsed and processed. So it's parsing the HTML right there, and that's what they say about Cold Fusion and PHP. Those scripting, they're called scripting languages because they're not compiled. They call it just-in-time compile. It's when it gets to the server, that's when it runs through the code and does the Cold Fusion functionality, or it does the PHP functionality, and that includes, not only the regular programming functions that you would find in a programming language, if then else and your loops and your things like that, but it also provides database interface, so you can get a connection to a database, write your query in SQL, and enclose that in either the Cold Fusion tags or the PHP tags, and when the application server is processing that file, it does that query. It sends this either to the database sends back a result set or a response, and that can then be used in the final HTML display. So if it's a table of data, you do HTML elements around a variable and loop through a query. So it's really pretty simple. It's very easy to learn. One of the pitfalls of it is that it's so easy to learn that people will try to do things not using any kind of programming patterns or design patterns, and what they end up doing is writing really inefficient code that it's so easy to write that you can write code that's a mess and too many lines of code to do something in Cold Fusion, and it will let you. And if you try to do things that will lock up your database and start blocking and things like that, it'll let you. There's no built-in protection against that. So those scripting languages are always kind of looked at as like secondary languages. Like real programmers know programming languages, and then pseudo programmers know scripting languages, but it really helps to have those programming skills if you're going to do that, so that you avoid those kinds of mistakes. But we always say Cold Fusion is so easy it's dangerous, and that was true, because a lot of the problems we had were because of really weird coding patterns. So next question, that is the last question. So I hope this almost half-hour video is what the grading rubric was looking for, and really enjoyed this class, and I'm glad I got a chance to learn some MySQL stuff, because I haven't used it in a while. I've been pretty focused on Microsoft SQL. So that's it. Stopping the video.